In the previous couple example, we learned to integrate to find the area with respect to x. Now, in some case, it's much more beneficial to find the area with respect to y and make it a lot easier. So let's take a look at the this next question. Find the area of the region bounded by the two curves y equals square root of x and y equal x minus 2. So again, let's start with our little graph. Okay. And we want this also being back and the x-axis as well. So note that the intersect of the graph y equals square root of x and the line y equals x minus 2 is at x equal 4 when y equal 2. And this graph here, the line x equal minus 2 have the y-intercept of negative 2 and the x-intercept as 2. So then we're looking at this line. So we are the region that we want to find the area is right here. Right? So note that earlier in the previous problem, we draw our rectangle this direction, which means this is why the region, that yellow region, being split into two different little area. Okay, so that's one region, and the other one have the upper curve is square root of x, the lower curve is the line y equals x minus 2. Now, let's say if we change the way we draw our rectangle. Go ahead and change the way we draw our rectangle. We still calculate this region. But if we just look at the rectangle in this direction, then there is no splitting the region into different parts. The only thing that has to change is we now have to evaluate the area under that region with respect to y. To do that, first we need to find the intersection of the curve with respect to y. Okay, so we can see that the intersection of this curve with respect to y, we will integrate this from 0 to 2. Okay, from 0 to 2. The second step is to set up and evaluate the integral. So the integral that we will set up is the integral from 0 to 2. And note that we have to do this with respect to y. So the function in there have to be in terms of y. So aside we have y equals square root of x. Let's solve for y. Let's solve for x in terms of y. This means x is equal y squared. Okay. And then the second part, we have y equal to x minus 2. So then x equal to y plus 2. So these are the two functions that we will use when we evaluate the integral with respect to y. So then here we have the curve that is on the right hand side. The curve that on the right hand side, that is the line x equal y plus 2. minus the curve that is on the left hand side, that is y squared. Just evaluate with respect to y. So then we have 0 to 2 of negative y squared plus y plus 2 dy. This is negative 1/3 y squared plus 1/2 y plus 2y. Evaluate from 0 to 2. So we are looking at negative 4/3 plus 1 plus 2. So negative 4/3 plus 3. So 3 times 3 is 10 with minus 4. This makes 5/3. Excuse me. So this would be, this terms here should say what, negative 1/3 y to the third. So then the negative 4/3 have to change to negative 8/3. Okay. Negative 8/3. And we also have 1/2 y squared. This means we have 2 plus 4. 2 plus 4 makes it. So negative 8/3 plus it. So this is 10/3. Let's compare the answer that we got here with the answer that we got previously when we evaluate this area with respect to x. And we did that in our first video, that is part B. So the line y equals square root of x, the curve y equals square root of x, the line y equals x minus 2, and the x-axis, this area is equal to 10/3. Now if we evaluate it again with respect to y, we get the same answer, right? So either way, let's take a look at the next problem. Y equal 2 minus x and y equal to square root of 2x minus x squared. I will not sketch the graph of this. I'll go ahead and sketch this graph using decimal, and then we'll put the rough sketch of the graph onto our paper. So as you can see, this is the region. This is the 2 curve, and we have the intersection here is at the 2 point 2, 0 and 1, 1. So y equal square root of 2x minus 2 is the blue circle, the semicircle, and the line y equal 2 minus x. Yes, so let's go ahead and copy this graph onto our paper. So the circle from 0 to 2. And then we have a line like that. So the intersection with respect to y is from 0 to 1, and we will evaluate this curve. Again, we want it in terms of y. So first of all, let's solve this in terms of y. Y equal 2 minus x. Excuse me, we will solve this curve. Yeah, that's right. We solve for x. So x is the function in terms of y. So x is equal to 2 minus y. Y equal 2x minus x squared, square root. This means y squared equal 2x minus x squared. I'll go ahead and combine like term. Excuse me, I'll go ahead and complete the square for the right hand side. So this I factor out the negative to the other side. So x squared minus 2x plus 1 minus 1 minus y squared equal to x minus 1 squared minus 1. I'll solve for x. So then x minus 1 squared is plus 1. So then now we have x minus 1 squared equal 1 minus y squared. So x is equal to square root of 1 minus y squared plus 1. So let's put this into our integral. So we look at the integral from 0 to 1 of square root of 1 minus y squared plus 1 minus the line 2 minus y. This is in terms of dy. So the integral from 0 to 1 of square root of 1 minus y squared minus 1 plus y. So here we run into evaluate the integral with a radical, which we do not know how to do yet. So let's table this. We'll come back later. Okay. What I want you to get out of this is we're not always able to find the integral of the area bounded between two curves, regardless the way whether we set up, whether you evaluate the integral with respect to x or with respect to y. So a lot of time we end up estimate the area using other means, say geometry if we can. Okay, so let's table this for now, and we'll come back to it when we have more technique of how to solve this type of integral with the radical. In the next one, I'm looking at the curve x equal y squared and x equal 9. Okay, so x equal y squared, this is the parabola that is open to the right. And the line x equal 9. Okay. So note that we are considering this area. This is the area that we want. Okay. And by setting the two equations equal to each other, we'll know that the y-intercept, the coordinate of the intersection here, when y equal negative 3, x equal 9, and when y equal 3, x also equal 9, I can evaluate this integral by only calculate the area from 0 to 3 and multiply it by 2, because it's symmetric, it's a parabola, right? So then we're looking at, okay, so the area from 0 to 3, and we will double that of the curve that is on the right minus the curve that is on the left. dy. This is 2. 9x minus 1/3 y cubed. Evaluate from 0 to 3.